Warm greetings. Welcome to Swayam Online Learning Portal. I am Dr. S. Ishwari, Head of the Department of Geography, Madras Christian College. This course, Climatology, is offered in the BA BSc Honors Geography program with 5 credits. Dear learners, we have designed with the comprehensive lecture series to provide you with the wholesome and insightful knowledge on climatology, its principles, practices, processes and applications in the real world. Today, we will be starting with the introductory lecture on Introduction to Climatology. In this session, we will set the foundation for climate, its elements, factors influencing climate and nature and scope of climatology and how it is significant in reshaping the natural and human environments. Before we enter into the nuances of climatology, it is essential to first understand the fundamentals of geography. Geography is the science of Earth's surface, environment and human interactions. It provides a spatial understanding of global patterns and relationships. We call geography also as a mother of all sciences. Branches of geography. The geography subject have 2 major branches. First one is physical geography. The physical geography name itself implies that it deals with physical features. That is, it has some sub branches also, that is geomorphology, hydrology, climatology, oceanography, biogeography. And the next important branch is human geography. Human geography deals with the man's interaction, that is human being who is going to be interact with the earth's surface. What are all the branches which comes under human geography? They are economic geography, urban geography, agriculture geography, population geography, social geography, cultural geography and industrial geography. Geography is the subject which integrates the natural sciences, social sciences and geographic techniques. How it is integrating all these 3 phenomena. In this diagram, in this inner part, you can see the major branches such as physical geography, human geography and the geographic techniques. And the semicircle, which is the first circle, is that representing about the sub branches of these main branches, and the outer semicircle which represents the other disciplines, how it is correlated or interlinked or interconnected with each other. So, if we consider the physical geography, the first one is geomorphology. This geomorphology is nothing but it is a study about land surface. The land surface in the other discipline, how they are dealing with, it is geology. And the next one is climatology. That is the course which we are going to discuss in upcoming series. The climatology in the other discipline is studied as meteorology. The next one is biogeography, which deals with the living things in the earth's surface and it is dealt with the biology subject. And the next one is the geography of soils and it is connected with the pedology. Then coming to the human geography, the sub branches are population geography. In the population geography, how it is connected with the other subject, other discipline, they are the demography which is connecting with the population geography. And then the next one is social geography, the social behavior and human perspectives of which is studied in geography. The same thing is studied in other discipline as sociology. And the next in the human geography is behavioral geography, the behavior of human beings, how he is going to interact with the earth's surface is studied in the geography. But the same thing is studied in other subject as the psychology, which is a trend today. The next is the economic geography, all the economic resources. It may be a agriculture resource, it may be a mineral resource, or it may be a industrial resource. Whatever the resources which is going to give an economic profit, that will be studied in geography. The same thing is studied or connected with other subject as economics. The next one is the geopolitics, but in the other discipline it is studied as political science. The next one is the historical geography. What all the historical events happen in the earth's surface will be dealing in this political geography and historical geography. In other discipline it is known as history. And what is the next one is geographic techniques. So, we know that there is two major branches, that is physical geography and human geography, but how it is managed, how it is interpreted, it is interpreted with the help of geographic techniques. So, what are all the disciplines which comes under, the branches which comes under this geographic techniques are the cartographic techniques, that is the geodesy is connected with other subject, and geographical information system is connected with the computer science discipline, and the next one is the quantitative techniques which we study in the geography is connected with the statistics, and we have a remote sensing technology which is used in geography, which is connected with engineering. So, you know that all these branches have been connected with the other disciplines. So, it is interconnected with the natural sciences, social sciences, and it is by the geographic techniques we are managing all these geographic natural resources. What is the importance of geography? Geography helps in locating a places, and it also helps in managing the natural resources. It explains about the human and environment relationships, and we can also have the urban and regional planning with the help of geography. And how the environment management, resources and disaster is managed is done by geography, is studied. So, it is most important. Provides the data for the climate studies and sustainable development. All these comes under the importance of geography. In the previous slides, we have come across what is meant by geography and what are the branches of geography and how it is important. But now, we will be dealing with climatology. The climatology, the term which have been derived from Greek word klima. Klima means a slope or inclination of earth surface, and logos. Logos means the signs of study. So, this is meant by the climatology, and scientific definition of climatology is that climatology is scientifically defined as long-term weather patterns of an area averaged over a long period of time. So, averaged over a long period of time, you have to keep in your mind that average. So, average means it is not considering the lowest level or low recurrence of temperature, for example, a high level of temperature. It is in between the average of the temperature, not for a single day or single month or 1 year, but it is a long period of time. How much the period is? It is over 30 years of data is considered, and it is analyzed for the climate, that is studied in scientific way is known as climatology. Climatology is concerned with the patterns. What patterns? That is weather patterns, climatic variations and causes of atmospheric phenomena. So, all these have been studied in climatology. Climatology is also essential for understanding global climate systems and global climate change. Next is the climate system. So, what is meant by climate system? Climate system is a whole system which deals with the geophysical system. So, geophysical system is that we have 5 important components in the Earth's surface. That is, first one is atmosphere. Atmosphere is nothing but it is the envelope of gaseous air masses above the Earth's surface. That is, the weather process occurs in this atmosphere. Atmosphere is most important because it gives us the oxygen and other important gases for living things and other important activities. So, atmosphere is considered to be the most important component in the climate system. The next is the hydrosphere. Hydrosphere deals with the water bodies. So, water bodies, it is not only the ocean or sea or whatever the water bodies which have, we deals with all the water bodies which evolves or which is flowing in the Earth's surface. That is known as hydrology. Hydrology is also one of the important component for all the living things. Because of this hydrosphere is all the living things have been evolved. Next one is lithosphere. Lithosphere is also known as a terrestrial surface. It is steady above the Earth's surface, that is the upper crust and the uppermost part of the mantle. So, this both the layers have been considered as a lithosphere. So, it influences the temperature and rainfall pattern of a region. Next one is cryosphere. Cryosphere is nothing but it is the ice and permafrost regions. It is most important for the reflecting of solar radiation, that we call it as albedo. Next sphere is biosphere. The biosphere, which consists of all the living things, that is plants and animals which interacts with the atmosphere and other spheres. All these 5 components exchange its energy, water and gases continuously, and this forms a whole system that is known as a climate system. Next one is elements of climate. Each and everything have its components or elements. The same way, the climate is also having its important elements. The first one is temperature. Temperature is nothing but it is the degree of heat and cold. Degree of heat and cold we experience day to day. Consider that today is a very hot day and compared to the previous week it was very cold. So, that degrees have been compared in the temperature, and this temperature varies from latitudes. What is meant by latitude? Latitudes and longitudes are imaginary lines which runs in the Earth's surface. In the globe we can see the longitudinal lines and latitudinal lines. The latitudinal lines are horizontal lines which runs from west towards the east, and it is also known as parallels. And the next one is the altitude. The altitude is nothing but it represents the height. The height is above the mean sea level. We measure that one from the mean sea level. And then next one is season. So, all these are varying because of this main element, that is temperature. The next one important component is air pressure. The force is exerted by the atmosphere. So, if you want to move one place to another place, what you will be doing? You have to exert some force. So, in such a way, if the wind have to move, there will be some forces. That forces will make the wind move, that is, it may be a gentle breeze or it may be a rough and a storm which we experience in our life. The next component is wind. The wind is nothing but it is a horizontal movement of air from high pressure towards the low pressure. Wind always moves from high pressure area towards the low pressure area. The humidity. Humidity is nothing but the water vapor content which is present in the air. So, that is known as humidity. So, because of humidity we tell in our day to day life that I feel discomfort because of humidity, and sometimes because of humidity there might be a precipitation. So, in such a way the humidity influences our day to day life. Next component is precipitation. Precipitation is the water released from clouds. It may be in the form of rain, it may be in the form of snow, or it may be in the form of hail. Next important component is the cloud cover and sunshine. It influences the radiation received on the earth. How it influences? The cloud cover. If it is going to be a dense cloud cover, it will restrict the penetration of sunshine inside the earth's surface. If it is going to be a clear sky, the penetration of radiation will be smooth and the incoming radiation will be high in that particular point of time. Weather vs. climate. What is meant by weather? Weather is a short term condition, that is it lasts for few hours or some days, is known as weather. Weather is what is happening now, and we say that today is raining, yesterday was sunny day. So, all these terms related to weather. The next one is climate. What is meant by climate? Climate, already we have discussed that it is a long term averages. How it is a long term averages? It is an average of about 30 years. And for example, what we expect is the most important terms which we use for climate. And climate example is Chennai has a hot, humid monsoon climate. So, this is an example of climate. We have a number of factors which affecting the climate. So, we will discuss one by one. The first and foremost factor is latitude. So, latitude or nothing but it is a horizontal lines. So, how it influence? That is, if there is an earth surface and the sun is here, if the rays of the sun falls directly on the earth surface, that particular region will be experiencing the hot type of temperature or weather. And if it is going to be a slanting rays, that particular region will be experiencing somewhat, that is cold temperature or weather. So, this is in this way the latitude will influence the climate. And altitude. So, altitude is a height. How it affects? For example, if you are going for a mountainous region and if somebody is in a plain section, did both of them experience the same climate? No. Why? In the plain section, comparatively to the mountainous section, it will be somewhat the warmer in condition. But if it is going to be in a mountainous section, your hill stations, you will be experiencing the chill or cold climate there. So, why it is? If we climb higher and higher and height increases, there will be the decrease in the temperature. So, because of this reason, the altitude plays a vital role in affecting climate. The next one is distance from sea. That is, the coastal region which experiences the moderate climate and the inland region which experience the extreme climate, it is also known as continentality. Next one is the ocean currents. What is meant by ocean current? It is an orderly movement of the ocean water in a same direction. So, that is known as a ocean current. The warm current rises temperature and cold current lowers the temperature. The next factor is the relief and topography. The relief means the landform. Either it may be a plain region or it may be a plateau region or it may be a mountainous region. So, if it is going to be a mountainous region, the mountainous region have both the sides. One is the windward side and another one is the leeward side. What is meant by windward side? The windward side is the region where the rainfall is received, and the leeward side is the region where there is a rain shadow region where it restricts the flow of rainfall in that particular region. The next one is vegetation. Vegetation, the dense vegetation increase the humidity and lowers the temperature. So, because of this continuous process, it in due course affects the climate. The next one is human activities. The human activities, the human interference involved, which have that is the deforestation and pollution, which in turn affects the climate of that particular region. Next one is importance of studying climatology. Why? What is the need for the study of climatology? Climatology helps us to predict weather and climate hazards, and it also supports the agricultural activity, in which season which crop have to be grown, what crop have to be selected, and whether it is needed irrigation or how far we can plan that agriculture. All can be done with the help of studying climatology, and helps in urban planning. How it helps in urban planning? The pollution and other impacts of human being which will control the urban heats. It produce the urban island. So, all these can be managed with the help of studying climatology. Important for aviation and marine navigation. How climatology is important for aviation and marine navigation? Aviation, to fly the aircraft, the climate, that is weather condition, especially the weather condition is most important. If there is a turbulence, if there is a foggy in nature, or if there is any weather disturbances, this climatological study or climatological knowledge will help the flight to fly in a lower cost and in a safer way. And next one is the marine navigation. The marine navigation is also one of the important factor. How it involves with the climatology means while traveling in the ship, the storms, hurricanes and other climatological phenomena or weather conditions will influence or affect the navigation of ship. So, if we study the climatology, we can manage it efficiently. It is also vital for climate changes, mitigation and climate policy formulations. Next one is scales in climatology. We have various scales in climatology, from local scale towards the global scale. The local scale is also known as a microclimate, that is the very small region that is within a 1 kilometer. The seconds which the weather condition which lasts for seconds, minutes, that is for example turbulence, wind gust, heat islands are the example of this microclimate region. The next one is a mesoclimate. The mesoclimate, the aerial extension is from 1 kilometer to 100 kilometers. It lasts for hours to days. That is the example is weather system, storms, heat waves. The next one is the macroclimate. The macroclimate, the region covers is 100 kilometer till the 10,000 kilometer. And how long it lasts? It lasts for years or decades. And what are the examples of this macroclimatic region is the El Nino, monsoon, climate trends, all comes under this macroclimatic region. The next one is the global scale. The global scale, it represents globally, that is the whole earth. It covers millions and millions of years, and example of that particular global scale climate is climate change and ice ages. Now we discuss about the nature and scope of climatology, that is earlier observations, ancient civilization before 1000 BCE. So, Egyptians, what they did, they have recorded the river Nile flood cycle and they linked with the monsoon patterns. Then the Babylonians recorded the cloud forms and rainfall to predict the weather condition. Then the Chinese, they did the systematic weather record from 3000 BCE. The first climatic data collection was done by Chinese. Indian civilization, Rig Veda and Arthashastra mentioned monsoon, wind and rainfall seasons. Greek contribution, Aristotle 384 to 322 BCE, in his writing Meteorologica, a first treatise on atmospheric phenomena, discussed about wind, rain, thunder, lightning and temperature. He also laid foundation for the philosophical understanding of weather and climate. Theophrastus 372 to 287 BCE described the seasonal changes and weather signs. Ancient Indians and Chinese weather studies indicates that in India, Panchangam calendar predicted monsoon timings. Kautilya's Arthashastra used rainfall data for taxation and agriculture. China, the first meteorological network under Emperor Wu Han dynasty, oldest continuous climate records have been done by Chinese people, and example of drought and flood reports have been generated by China contributors. Next one is medieval period, 5th to 15th century. Islamic scholars preserved the Greeks' work and expanded them. Avicenna wrote on condensation and winds. Al-Biruni describes about monsoon system in the Indian version. European monasteries maintain the weather diaries for the religious and farming use. Renaissance and the birth of measurement. 16th and 17th century, there evolved the inventions of instruments. First and foremost is the thermometer. Thermometer, which is helpful to measure temperature, which have been invented by Galileo Galilei in 1593 and then by Santori in 1612. Barometer. Barometer helps to measure the atmospheric pressure, which have been invented by Evangelista Torricelli in 1643. Hygrometer have been invented by Francisco Folli in the year 1664, which helps to measure the water vapor. Rain gauge have been invented in Korea in 1441 and in Europe 16,000. This rain gauge is helpful in measuring the rainfall. The systematic meteorological measurement began in this century. In 18th century, the data collection and early weather mapping have been done. First meteorological network in Europe, that is Germany, France and Britain, have done a map work, regular weather recording by observation. In this century, observation and initial mapping work have been done for weathering. Early attempts to correlate weather with geography and meteorology emerged as a part of physics and geography in the 18th century. 19th century laid the foundation of scientific foundation of climatology. Luke Howard, 1802, classified the clouds as cirrus, cumulus, stratus. Alexander von Humboldt mapped the isotherms lines and framed the temperature zones. Waldemar Coppens developed the first global climate classification in 1884. Julius Hahn, the father of modern climatology, have come up with the handbook of climatology in 1883. Early 20th century, the statistical climatology, that is the growth of regional climate studies using averages. So, all the statistical techniques have been evolved in this early 20th century. Thornthwaite 1948 developed a moisture indexed based classification. Copenhagen mapped the revision of global applications. The dynamic climatology 1920 to 1950 have focused on air circulations, jet streams, planetary waves. Carl Gustav Rossby explained the atmospheric wave patterns. The weather forecasting becomes a more scientific. The links established between ocean and atmosphere have been evolved in this century. Physical climatology have been evolved in mid 20th century, a study of energy balance, solar radiation and heat transfer, which understand the climate as a part of Earth's energy system. The measurement of albedos, greenhouse gases and radiation balance have been done in this mid 20th century. Development of global meteorological organization have been done in 1950s, where World Meteorological Organization WMO have been founded. The standardized data have been collected globally. International cooperation for weather and climate research and global climate databases have been established. Satellite and remote sensing era in 1960s to 1980s. The launch of first weather satellites, that is TRIOS, in US 1960s have been evolved in 1960s and 1980s. It observes clouds, storms and sea surface temperatures. The remote sensing revolutionized the data accuracy and numerical weather prediction models have been evolved in this era. Computer modeling and simulations have been evolved in 1970s and 1990s, developed global climate models. The simulation of Earth's climate system under different scenarios, integration of ocean atmospheric system have been done. Enhanced predictive capabilities for climate change have been evolved in this century. The study of climate change in late 20th century have been done for rising in CO2 levels and greenhouse gases effects, and ice core and sediment data reveals the paleoclimatic changes. It increased the awareness of global warming, and IPCC have been formed in 1988 to assess climate changes. In 21st century, there was an advanced tools in climatology where AI, machine learning and GIS have been evolved in this century, and real-time monitoring have been done for temperature, sea level and glaciers, and climate risk maps have been constructed, and disaster preparedness have been done with the help of this advanced tools. The global network sharing opens the climate data of NOAA, NASA and IPCC. The climatology in India have been evolved in the earlier developments. India Meteorological Department have been established in 1875. Pioneer work on monsoon climatology have been done, and the systematic weather observation have been done by IMD. Yearly rainfall and temperature records maintained by British scientists. Indian contribution to the modern climatology, Sir Gilbert Walker have discovered the southern oscillation where INSO and monsoon have been linked. S.K. Banerjee, P.K. Das, S.K. Srivastava, monsoon and tropical climatology resource have been monitored by them and given research for these monsoon and tropical climatology research. Establishment of National Climate Center in Pune have been evolved in this era. IMD's roles in monsoon prediction using numerical models. Modern branches of climatology are physical climatology, which deals with the energy exchange and physical process; synoptic climatology, which is about weather maps and pressure system; dynamic climatology, which is about air motion and atmospheric dynamics; applied climatology, which applies in all the sectors such as agriculture, health and planning; satellite climatology, where the data have been collected with the help of satellites and sensors; paleoclimatology, where the study of climates in the past have been done with the help of ice cores and fossils. Interdisciplinary nature. The climatology is interdisciplined with various disciplines, that is meteorology, oceanography, ecology, GIS and remote sensing, environmental sciences. Applications of climatology have been done in the sectors of agriculture, architecture, urban planning, transportation, environment. So, all these sectors, the climatology plays a vital role. Global warming and climatology. So, global warming is one of the triggering factor nowadays that have been studied with the help of climatology. Ozone layer depletion, that is the ozone layer is found in stratosphere in 10 to 50 kilometers, which have been observed as a harmful ultraviolet radiation, where CFC is the most important cause for this depletion. So, this have been monitored and this have been managed with the help of climatology, and Montreal Protocol in 1987, the global agreement to reduce CFC have been formed. The climate and human life. The climate plays a vital role in human life. It influences the agriculture, it influences the architecture, it influences the health, economy and migration. So, all the extremes and all the climatic hazards have been managed or interconnected with the human life. Recent developments in climatology, the recent developments are the involvement of remote sensing and GIS in climatology. The numerical models have been prepared in the climatology to have a prediction and mapping for future model, that is planning. AI and machine learning have been done, and where the detection of climate anomalies have been done with the help of machine learning. IPCC and COP summits have been addressing the climate change mitigation and in the global level. Future directions in climatology: integration of AI and machine learning for the prediction, use of IoT based climate sensors, climate adaptation and resilience building, reduction carbon footprint and emissions, renewable resource development, monitoring global temperature and sea level rise. International cooperation for sustainable climate policies have been done for managing the climates throughout the world, that is globally. The summary of this lecture is, we have discussed about what is meant by geography, what are the branches of geography, and what is the importance of geography, and what is meant by climatology, what are all the branches of climatology, elements of climatology, and how it is interconnected with all the disciplines have been studied in this lecture. The next is that the nature and scope of climatology have been studied or discussed in this lecture. Then we have come across the significance of study of climatology. So, all these have been summed up in this lecture. In the upcoming lecture, we will be discussing about what is weather, what is climate. Thank you.